Hello, this video is to help grade 9 students learn how to model a line or a line segment on a flag for their summative. And we're going to use Desmos and a linear relation. And I'm going to just click in here to show you the end result. I've got the pride flag here, and I chose two endpoints. And I actually end up with this quite messy linear relation. And I also have some restrictions here. So I'm going to go through some of the skills that you'll need to be able to get to this at the end. So hopefully you remember from the staircase modeling task earlier in the semester that you can import an image into Desmos. So here you click the add item, go to image, and then it will prompt you to add some sort of JPEG or PNG. Here I've got the pride flag, and I'm going to show you as well. Here we would start from 0, 0. These sliders are going to allow you to approximate points on the coordinate plane. So I will share a link to this page so that you can actually play around with the slider. So I'm going to move these around, and you should see a point right now moving along the positive side of the x-axis. But the line segment that I want to model is between the blue and the brown areas of the flag, moving downward to the right, all the way to the x-axis here. So some things that maybe I want to consider would be the flag and its key points here. So I'm seeing in the top left corner, there is a point, -5, x value, and a y value of 2.65. Well, I think I can use that y value, 2.65. So I'm going to move that here, and you'll notice that, well, the slider only goes to 2.6 or 2.7. So I'm going to just show you that I can mouse right in there, but at 2.65. And here, for this x value, I need to move it and around -4.9, -4.8. But if we zoom in a little bit, which sometimes can help, I think we can notice that maybe, and we're not always going to be laser accurate, but I think -4.85 will suffice. So I'm going to go here. Mouse in, put 5. Okay. This point reasonably looks to have a y value of 0 because the point is on the x-axis. So as I go here for my next slider, my second point, y2 can stay at 0. x2, I'm going to need to move to the left. And -2.3 isn't quite it. -2.2 looks a little far. And I've been playing around with it. I did try -2.25, but I noticed when I did the line, it wasn't right on that border between the blue and the brown. So I refined it a little bit. I'm going to go with -2.22. Now you'll see here that obviously I have the equation. I'm going to move that down. Or maybe what I'll do is I'll move this up. I can actually get Desmos to determine the slope for me. So watch what I'm going to do. And you might know that slope is usually represented with the letter M. And I can actually go y2, subtract y1. And I'm going to put a bracket around that, divided by x2, subtract x1. Now you'll notice it's a very long decimal. And you'll also notice that in my final equation, I don't use the decimal. So here's a nifty little function here. I'm going to go here, and you'll see that it is going to tell me that the slope is negative 265 over 263. This makes sense. It is a line segment, so it will have a slope, and it is moving downward to the right, so it will be negative, the slope. I'm showing the same information here, where I substitute it into the formula, I evaluate, and then here we have this awkward fraction with decimals, and I just multiply top and bottom by 100 and end up with the same value. I'll share this Jamboard as well later on. Well, the next idea would be determining the Y-intercept. So what we're going to do here is we're going to use that slope that we determined, and we're going to use one of the points. Now, I know what you might be thinking. You might be thinking, well, I don't remember a point that looks like this. So I'm just going to show you. I'm using the point that was on the x-axis. We can tell this because the y value is 0. If you're concerned about changing to fractions, once again, you can use the Desmos calculator to do that. So I'll show you once again. I believe this value, I'll just add an expression here. The value was negative 2.22. And if you wanted to right away here, gives you that. Obviously, we could also show that understanding here. And if we started with negative 2.22 and we multiply top and bottom by 100, then we have 222 over 100, and that's negative, of course. Those are both divisible by 2. Like that. We're going to take our slope. We're going to take our point, which has an x value and a y value, and we're going to substitute into general form for a linear relation. Y equals mx plus b, where x and y represent any point on the line. M represents the slope, and the b value is the y-intercept. We don't know the b value, so here we're going to be determining it. So for y, we substitute 0. For the slope, we substitute negative 265 over 263. For our x value, we're going to use a fraction just because it becomes a little bit difficult if we are mixing decimals and fractions, so I just thought I'd be consistent and use fractions. And then here, what we're doing is we're multiplying numerators and denominators. We end up with this fraction, 5,883 over 2,630. Subtract that on both sides. And we end up with this as our y-intercept. Makes sense. It should be a value that is less than 0, so it's negative. Let's go to the final page. We have a slope, we have a y-intercept. Therefore, we can substitute those into our general form. Y equals negative 265x over 263. Subtract 5,883 over 2,630. Lots of fractions, lots of exact values, sometimes a little more precise than, let's say, a decimal, especially if we start to round. So we're just going to click in here, and you will see that we have that line segment. Now you'll wonder, when you do yours, you might not actually have those same endpoints in your line, because if I don't have this curly bracket, you'll see the line like this. So part of my design was that I called the first point the leftmost point, and I called the second point the rightmost point. So here, I'm going to create this double inequality. And I'm going to put x1 on the left side. And it's less than equal to any of the x values in my line that I would like. And that is less than and equal to my x2 value. Essentially, what I'm saying is this. I want Desmos to show the x values between my 2 points, okay? And not just the x values, but those points on the line. So the x and y values there. And that's how you do this part of the task. We modeled a line segment on a flag. We used the pride flag here. And we determined the slope. We determined the y-intercept. We entered the linear relation into Desmos, and we used our x values to create restrictions to really accurately model the line. Thanks for watching, and bye for now.